Perhaps I'm getting a little too prolix, too verbose. I ran out of memory and I still haven't got round to figuring out how to free up multiple gigabytes on my RAM chip in my camcorder. At the moment I'm really only using 7G when the capacity of the memory chip is 32. So I keep running out of time. So I had to stop and download the first session to free up some space so I can record this one now. Okay, so we were finding the... We're in the middle of finding the transition function, delta dashed, for the DFA capital D. Right? So we're just going through the various states. Now I've drawn the NFA again here because otherwise it'd be difficult to follow. So we'll need this. All right. So state 3 in the D. So we correspond to the state 3 in the NFA. That's here. So we're here. And the input symbol is A. So what does 3 do? Well, it just goes to 1. And is that it? Oh, okay, it goes to 1, but 1 has an eta arrow, so it goes back to 3 as well. So 3 on A, because of the eta arrow here, so 3 will go to 1, but 1 has an eta arrow, so immediately you go to the state. You don't have to wait to reading of the next input symbol. That's what eta does, it just goes immediately to the next one. So 3, where are we? Yeah, so 3 here, when an A comes in, so it'll do here, it'll go to 1, and 1 has an eta, so it'll go back to 3. So this will go to 1, 3. So you now have like two machines. Before you had one machine in state 3 in the NFA, okay, and that machine now splits because of the eta. So you'll have one machine in 1, and due to the eta, you have a copy made, a copy of the NFA, and it'll be put into state 3. So the state then of the D will be, the set then of 3 that state will now change to this 1, 3 on A. Okay. Because in the NFA, in 4, 3 goes to 1 on A, right? And 1 goes to 3 with the eta arrow. So this goes to here because of the eta arrow here. Okay. Goes to state that. Okay. Now what about B? What does 3 do when the input symbol is a B, little b? Well, there's no output arrow here with a B label on it, so it dies. Okay, so it just goes. There's no output state. It's the empty state, just 0. Okay, so it dies effectively. Right. So we've done states. What have we've done state 2, A and B. We've done state 3, A and B. Now we're doing state 1, 2. Now remember there were 8 of them. Okay. Now we're not going to do them all. It'll take too long. And here's like a summary of the results. It's already quite complex, and you know that, right? DFA is typically an equivalent DFA of an NFA. Usually has many more states, and hence a lot more complicated. Okay, so well, just do a little bit more. So the state 1, 2 in big D, what does it go to? Well, what does 1 go to on 1, 2? Oh, right here. Sorry, I jumped ahead. Okay, so what does the state 1, 2 do when the input is A? And here's what does state 1, 2 do when the input's B? Right, so step by step. Okay, so the state 1, 2. What does that mean? Well, this would mean that the state 1 and 2 of the NFA, that would correspond to two machines, two NFA machines, one of them in state 1 and the other one in state 2. And these two machines independently read the input A. You know, the latest input symbol to go in is A, right? So what does state 1 do and what does state 2 do? Well, let's use this diagram. Okay, so state 1, an A goes in, okay? So state 1 dies, okay? Because there's no output there's no output labelled A. So 1 dies, but there is an eta. So it goes immediately to state 3. And because, hold on. So state 1 dies, okay. But there is an eta, so it goes to state 3. Now I guess it depends. Now here's where the nitty-gritty comes in. Remember in the previous session towards the end, talking about whether you follow the eta arrows before you read the symbol or after you read the symbol. So here's a case of where it would be relevant, I guess. These details were not spelt out in the text. We're just sort of learning them from deduction. All right. So why does 1, 2 go to 2, 3? What's his reasoning? Okay. So why? So there's no 1 here. It died. Now why would that be? Because there's no exit transition. There's no exit arrow with an A on it. Okay, so 1 dies. But there is an eta, so it goes to 3. So there is a 3. There will be a 3. This set, in other words, the state of D, will have a 3 in it. The next state will have a 3 in it. That's here, and that's due to this eta. Okay. Now, why is there a 2? Oh, the 2 here. Well, the 2 under A, right, could loop back to itself. And it could go to a 3, because there's an A here. But we've already got a 3 from this one. So when we do the union, remember that all that talk about unionizing, that way you throw out the copies, the multiple copies. We don't want to have two machines in state 3, two NFA machines in state 3. So by unioning, we get rid of the copies. And so effectively we're just left with 2, 3. Okay, so the two came from here. Okay, it could loop back to itself. And this 2 leads to a 3, so we have a 3 here. And the starting, the 1 here, with the eta arrow gives you a 3 as well. And so you've got 2 copies of 3 by using the union. The big R is the union of blah blah blah. So we throw out 1 copy, so we're just left with 2, 3. Okay, right. Now why is that? Well, it's just what it is saying. So the 1 points to no states with A. Okay, so it dies, right? The 2 points to both 2 and 3 to itself. Okay, with A arrows. Okay, and states 2 and 3 have no eta